You said, what do you do when it rains? Yeah, I just tarp anything important. But most of it is actually fine. Most of it doesn't matter if it gets wet. Including, actually, surprisingly, most of the electronics, too. It doesn't really matter if they get wet. But some of them it does. So I normally tarp my motor. That's the most important thing to tarp. So listen, guys, big updates on the reactor. As you can tell, it's insulated now, okay? Because we have to do what we need to do to get these oils. Because let me tell you guys something, okay? Last night, I got a phone call. It was from P. Diddy, right? He called me and he said, listen, I'm going to jail. I need some oil for the sale, okay? And he was like, I trust you to make me some oil tomorrow. So I said, okay, the only way I can do that is going to be insulating this reactor and also adding another waveguide. So now we have 3 microwave magnetrons coming in through the center. Grayling Gaines, thank you for the $10 on Cash App. I appreciate you. You're always donating, Grayling. So much love to you, much blessings and gratitude your way. You help out this project so much. So yeah, that's the thing, right? Listen, on a human-to-human level, okay, I'm just trying to help a G out. I know he's done some things. He's going to get his karma back in that cell. But I could at least make it a little bit less painful for him, giving him some oil. So that's what I'm going to do. So we're making oil today, guys. And that's period. That's a matter of fact. Like I said, we got to insulate it. We got up to 6 that we can turn on at once. Right? So hopefully today, that'll do it. So as you can see, the yoga ball's already been sucked dry. That machine is currently under vacuum right now. And it's holding the vacuum. Thank God for that, right? Every single weld and gasket is holding up. There's so many connections, you never know. So we got that. We already got plastic in. So all we got to do now is just turn it on. So, hey, without further ado, let's turn her on. All right, so we got it on. 6 magnetrons total. So right now I added a 3rd waveguide to the middle, okay? So we have 3 in the middle, 3 at the end, and 2 at this end here. Right now I'm running the orientation with 1 on in the beginning, right? 3 on in the middle, and then 2 on at the end here. So hopefully with that orientation, we'll see what that would do for us and give us, you know, if that's going to be sufficient in terms of the heating coverage. The fortunate thing is this, guys. Like I said, right now I can only run 6 at once, even though I have 8 mounts. What's up, 1, 2, 3? Once I get my power supplies, my better industrial microwave power supplies, I'll be able to run way more than 6 at once. In fact, I'll be able to run 9 to 10 at once. Zach, the BOK, thank you for the badge on Instagram, man. Much love to you. You're always so grateful. So, I can already tell, it looks like the yoga ball is already starting to get some vapors in there. I mean, as it should, with this much power going in. So did you get new PPE equipment? I have the standard things, respirator, you know, the gloves, of course, eye protection as well. The next biggest safety equipment thing I'm gonna get is going to be my oxygen sensor. So that way I can make sure that there's no oxygen in this reactor with absolute certainty before we turn it on, right? But for now, I just pull the vacuum. We see the yoga ball gets sucked to dry, turn it on, and it's been fine, right? So, as I always say, right, with this machine, it's not like some type of it's not like a Nikola Tesla plasma device, right? When you turn it on, there's really nothing to see. It's just fans blowing. That's really it. That's the only way you know it's on. There's barely anything to hear, barely anything to see, except for when this yoga ball starts filling up. So it's kind of a waiting game once you turn it on, right, for that plastic to start being broken down. But it looks like the yoga ball is starting to fill up already. Thank you, Josue, for the badge on Instagram. Thank you for the $2 donation on Cash App. Al Flores, thank you very much for the $2 on Cash App. I appreciate you very much. What's up, guys, on Facebook? What's up, David Clark? Much love to you, man. What's up, Patrick? Patrick Hawkins, much love. Ty Horton. What's up, man? What's up? What's up, Chris? On Facebook. Can you name the machine Megatron? You know, that's a good question. That's a good question, guys. Okay, so this machine, if it within its process, is called a shaftless auger microwave pyrolysis reactor, or for short, a SAMPR. But what should the actual name of the machine be? That's the question. What should we name the actual machine? You guys let me know, honestly. This is our machine. This isn't just mine. That's the real question there. You say you don't listen. If this is what I think it is, you need to keep it on the low. It's too late now. I already been showing the whole world, and I will continue to. No stopping me now. Let's see, YouTube. What's up, guys, on YouTube? What's up, everybody on YouTube? Much love to you guys. Thank you, JDI. I appreciate you, man. The Magnetron 7000. You said this is the diddler device. What's up, Zai myself? Yep, I got insulation on it now. We're in the hopes of that will be enough. We know that yesterday we came awfully close to getting oil. In fact, we had oil forming up at the top of the reactor, but not going through the pipes. But the pipes were starting to heat up before we had a leak. Now with insulation, we should be able to get it. I mean, honestly, I know that this machine is still not operating at full power. In fact, it's just operating at half power. So, you know, we can't expect the most from it, but still, with insulation and the temperatures we're getting with even this much power, we should be getting oil, okay? Honestly. Because the only other thing we can do at this point, if we only get oil from today's run, as long as nothing goes wrong, no leaks or anything, right? The only other thing we could do is add more power, okay? I should call it Diddy's Pines, Diddy's Pines. Pines. What? Wait a minute. Wait, what do you... Hey, what's up? Much love, New Jersey. Thank you, G-Maze, for the badge on Instagram. We said, why is everybody talking about Diddy? I don't know why everybody's talking about Diddy. I don't even bring him up. People always been talking about Diddy in my live streams. I don't even bring up Diddy. I never even mentioned him before. You said, I don't tune in for 1 week, and this thing has evolved into a whole new creature. Yeah, I work crazy. Guys, look, the yoga ball is filling up. You're seeing it happen live. Yoga ball is filling up. You guys on YouTube can barely see it, but you're going to see it in a second when it's a complete ball. Let's see if we got some heat. Yeah, we got some heat at the front. That's good. Oh, Facebook went out. Great. We're back online, Facebook. Call the machine the Jesus incinerator? But no, because wouldn't that be disrespectful? Because that means the machine is incinerating Jesus. No, we're not going to name it that. Where are the actual good names? Guys, what should we name this machine? Seriously, come on, give me some real names. Why is Facebook going out? I'm sorry, guys, on Facebook. I don't know why Facebook's going out. We got this on Ethernet. I'm not sure what the heck is going on. Oh yeah, we got insulation feeding time on YouTube. The pyrolysizer. Why would you say I should name the reactor Sperm? Y'all crazy. Y'all crazy. Where are the actual good names? Where are the actual good names for this individual reactor? Okay, I've built 5, so this is its own individual. Oh, Flores, thank you for the $2 on Cash App. I appreciate you, man. Sorry, guys, on Facebook. It's going in and out. Call it the Showboat. No, we need some actual good names, man. The Pyrolysis. Said, how about creating an acronym? We already have the acronym. It's called the SAMPR, the Shaftless Auger Microwave Pyrolysis Reactor. But I'm saying that's the acronym for the machine and what it does. But it's technically Mark IV was a SAMPR as well, because it was a shaftless auger microwave pyrolysis reactor. I'm saying the name for this individual machine. Call it polyethylene. Call it Zeus. Yeah, right, 1, 2, 3, exactly. These people are obsessed with Diddy, for real. I always tell the people the same thing. I'm not talking about Diddy, so why are you talking about Diddy? The plastic reactor. I think it'll come to us, guys. It'll come to us. Oh, now you guys on YouTube can see my ball starting to fill up. Now you guys can see it. The jab juicer. How about we call this machine the natural jab? Let's see how these pipes are filling. Well, the chamber's definitely hot. That's without a doubt. Yeah, the chamber is definitely getting hot. What are we? We're only about 10 minutes in. We got to give it at least like 20 minutes to warm up, right? Get up to temperature. The insulation sure will make it a lot quicker. I mean, no matter how you put it, in the beginning, as the machine needs to warm up, it's going to consume the most amount of power. But the whole benefit of it being continuous is that once it warms up, we don't have to turn it off to load more plastic in. Once this machine warms up, we can still load plastic in while it's nice and red hot. And that is why I hypothesize that the continuous operation is the key for high efficiency. Okay? Because we gotta wait. We've been running it for 10 minutes now. Actually, less than that. But it's still warming up. I mean, no matter how you put it. My bad. Goodness gracious, it must be that fiberglass. It's the wind blowing this damn fiberglass in my lungs. Hold up. Goodness gracious. That's why I don't like messing with this bloody fiberglass stuff. So yeah, that's the whole idea. Today we're not going to be continuously feeding it. Today, like I said, the main goal and mission is oil. Okay? So looking at the sight glass, we got oil droplets on the sight glass, okay? Now, here's the thing. Here's the thing, guys. Okay, let me tell you something. We ran the machine yesterday. We had a leak after about an hour of running it. Okay? And then at that point, we saw some oils. I didn't open up the machine on live stream, but I opened this lid today. And when I opened the lid, a whole bunch of oils dripped down. Okay? I wish I was recording. Of course, this stuff happens, you're not recording. But the point is, oils are forming, they're just not going up through the condenser pipes. But now with insulation and more power, it should be. Thank you for the $9.99 super chat. Slept on YouTube. He said, go gotcha. I appreciate you. What is go gotcha? What is that? Is it the Rockefeller reversal tool? Yo. Yeah, so I do notice it's heating up way quicker with insulation. So that's good. Plus, all we look for is improvements. If we improve every day, it may take a year, but we will get where we want to go. The only issue is when you stop progressing, when you stop improving. But we're improving every run, every time we go live. This machine is running better and better. That's all that matters. And every time we run this machine, my balls get sucked and my balls get filled. So can I complain? Can I have any complaints? I can't have any complaints. Instead, call it Diddy's oil. How about we call this Diddy's babysitter? So I do have a thermometer on the base of these, the pipes coming off of it. And right now it's at 54 C, which is about probably a little bit over 100 degrees Fahrenheit. We want that pipe to be probably about 100 C or about 212 Fahrenheit. That's what I reckon would be the temperature necessary to give it fuel. Or to give us the oils, actually. So, it's heating up real good. Heating up real good. I should have got a timer so I can know how long I've been running this for. Well, according to the live stream, I've been running it for under 20 minutes, actually. So, I wish... And let me ask you guys a question. Do you think it would be worth all of the hassle to put a view glass on this thing, right? So we can see the inside of it while it's running. Now here's the thing about a view glass. You can't just put a view glass. It's too dark in there. You'd have to put a view glass and a light. You guys think it'll be worth it? Because obviously we have the sight glasses for the oil and the plastic going in. But do you think the view glass to actually see the inside of it would be worth it? I've had a view glass before on my Mark III and my Mark IV machine. And you could see, like, for example, if plasma formed on the inside, you could see it. It's not necessary at all. In fact, it's a liability because it's another port that could fail and that could leak, that could break, you know, the glass could shatter. It is a liability, but borosilicate glass would work fine. So just throw a GoPro in there. I don't think it would survive. In fact, there's pretty much nothing organic that can survive this environment. Because what happens is, since we mix it with carbon, when the microwaves heat up the carbon, that individual piece of carbon could get up to like 1,000, 2,000 degrees Fahrenheit. Very hot, 500 to 1,000 C. That's pretty much enough to destroy anything organic. And, you know, that carbon is so hot and it's touching the plastic, which then heats it up and breaks it down. Or whatever is in there for that fact. So are you an engineer? No, I'm not an engineer. I'm self-taught. The glass could make sense. You would see how complete carbonization, but you mentioned the pitfalls. Now here's the thing. I can get a prefabricated sight glass made out of borosilicate, a tri-clamp fitting. So now when I say it's a liability, I'm not saying like it's going to be a failure point like that or a big deal. It really won't, because the borosilicate is strong stuff. Like I said, I won't be building it myself. It'll be prefabricated. But, you know, that's going to be an extra expense as well as an extra hole that we have to cut and weld something into this machine. So I just wonder if it'll be worth it. That's all I'm asking. We'd have to actually have two, because like I said, we have to have a sight glass and a glass that we can shine light through, because it's too dark in here. Right? It's too dark for you to see anything if you don't have any light going in. You know, they actually make these manways, right? They make these manways with like a glass right there. You can see in. Hey, look, the ball is filling up, y'all. Y'all see it happening. How long are we in now? We are about, we're probably about 15 minutes into running the machine at this point. I'm gonna get a timer. The pipe is now at 61 C. Like I said, I'm looking for that pipe to reach 100 C. I reckon at 100 C, we'll start to get oils to come over, because right now they're just refluxing. Since this is a mere test run, and this is a mere oil extraction run, we're not spinning the blades right now. We're not loading in plastic right now. We are merely doing the tests to see how long it takes and what the temperatures it required for us to start getting oil coming over, because obviously we've been getting natural gas. You can see the yoga ball filling up. So where you located? I'm in Georgia. You said more opportunities to fail. I think no. Yeah, to be honest, I put the view glass on my Mark IV reactor, and I ended up covering it up because I barely used it, you know? I didn't like being that close to the machine anyway when it was on. What's up, Yuki? We're going to take the first step in educating the Haitian community on economy, finance, and love. Excellent. Great work. Great work. Name it the naturalizer or the pyrolyzer, using the force of raw to transmute man's folly back into usable elements. Okay, that's an interesting comment there. Let's see. Cracking won't be an issue if you just make the glass thick, though. Yeah, borosilicate will work fine with the view glass. So the view glass is not really going to be an issue in terms of like a safety thing. So let me give you some reference, right? My Mark IV machine would take about 40 minutes to an hour to fill up the first yoga ball. This machine has not even been running for 20 minutes, and look, first yoga ball is filling up. So what's up, Miss Deming, what's up? So obviously, I mean, as it should be, with how much power we're putting in, it should be working better than my last machine that had less power. And it's gonna be the same thing when we do get oils, right? When we do finally crack this code, we're almost at 70 C, by the way, guys. We're at 68 C. The temperature's rising. We're almost there. When we do finally get to that point, when we get these, ooh, it's hot. Ooh. Hey, I always tell you guys, right? You know the metal's hot enough where you know, okay, I wouldn't want to put my raw balls on this. I would not want to put my raw balls on this right now. So this is real hot. That's what we like to see. Temperature's rising. Balls getting filled. What can I say? Look at that. Yoga ball almost completely filled up of natural gas from plastic. And this is why I say, guys, this is why we hope to see being able to run a generator off of this natural gas, because we make a lot of it. 20 minutes in, a full yoga ball damn near. So can you insulate the end part? Yes, I can, and I really should, but it just looks cool. That's hot. I didn't insulate the, well actually, well I can, yeah, I can insulate it and still be able to open and close it. I didn't insulate it on my last reactor either, mainly just because it looks cool. If I insulated it, this thing would look like a giant carpet, a circular, it look like a rug. You said, my 6 kilowatt unit is up and running in about 10 minutes at 5 or 6 gallons per hour, full tilt. Tony Diesel, what are you talking about? And although, by the way, shout out to you, Tony Diesel. You're an OG, man. I've seen you on my YouTube channel for like a year or so now. So your balls won't be raw anymore after putting them on there? Yeah, I gotta get a little sizzle. You said efficiency over beauty. That's true. That's true. That's true. Well, hey, I'll let you guys decide. Should I insulate this front end? I wonder how much we're losing. How much heat we're losing collectively by having it uninsulated. You guys let me know. You decide. Julian, you should make a fluidized bed reactor with water at 500 degrees Celsius. I wonder if that type of thing will work with microwaves. Okay, so let's say we were to use a lot of water in this machine. The microwaves are really focused on the water more than anything else, because microwaves at 2.45 gigahertz have been tuned specifically to heat water. They just also happen to heat up carbon and iron and graphite super well as well. That yoga ball's getting real full. Who wants it? Who wants the ball? Because it's getting full. Looking very good. We're at 73 degrees centigrade, almost at 100 degrees centigrade, which is 200 Fahrenheit, which I reckon is going to be the temperature oil start coming over. But that sight glass is looking real foggy right now. I'm going to take a closer look at it. If you guys can, yeah, you can see the sight glass. It's completely white. Take a look at that. We got it. You saw the ball fill up here. Where we at? We're about 25 minutes into the run. You saw it fill up here. Oh, it's time to replace it. This ball's getting too full. It's starting to come out. Well, actually, when I bounced it, the port came out a little bit. Never mind. We can let it fill up a little bit more. It's almost full. And so people ask me, okay, Naturejab, you got these balls. What do you do with these balls? So what I do with these balls is I compress them in propane tanks, okay? And then you have compressed natural gas at that point. You use it for anything. I used to use it for my distiller to distill the oils that would come off of the machine, okay? Another thing I like to do, it depends like on how many I have. Like obviously right now I have one. Sometimes I have up to 3 balls. When I have up to 3 balls, I do like to put them in people's mouths. If they don't pay attention to my class, you have to incentivize people. At the end of the day, if you want people to learn and pay attention, you have to incentivize them, right? So it's called a negative incentive. You know, you're definitely going to pay attention because you're not going to be able to survive 3. Okay? And that's just what it is. So it's looking very good. We're at 80 degrees centigrade on the pipe temperature, about 20 degrees centigrade away from 100 degrees centigrade, which I reckon, well, look, here's the thing, guys. At 100 degrees centigrade, water will start coming over because that's when water boils, right? And that means the temperature of the output pipe is hot enough to boil water. So that means at the minimum, we're going to get water coming over because, mind you, the past many, many runs we've been running, we haven't even got water coming over on the oil condenser side, right? Let me actually change this ball because this machine is such a beast and it makes so much vapor that if I leave this ball to fill up, the ball will literally just blow up. It literally will. So let's change it because it's getting tight now. And these vapors are coming out at so much pressure, I can literally hear it. You can see it. You see it. Let's see if they're flammable right now. It probably is going to blow itself out. It won't even light. They're coming out at so much pressure. You see why the ball's filled up so quick? I shouldn't be breathing that in, so I'm going to hook up this ball right away. But that's why I say, listen, the vapors are coming out at that much pressure with only half power without the blade spinning. With all those things combined, full power, blade spinning, that's enough of a flow rate to run a generator. Guaranteed, I promise you. That's enough of a flow rate to run a generator that will then run this machine. Okay? We gotta do it, of course, but that's my hypothesis. And guess what? If we can run a generator off of this machine's fuel and run the machine with that generator completely, then it doesn't matter. Energy is not even an issue anymore because the machine runs itself. The machine can take 30 hours. It can consume a megawatt. It doesn't matter because it's running itself. It's sucking itself off. That's the goal. Because at that point, you're like, we don't even have to worry about energy anymore. We can leave this uninsulated at the front if we want to. It's running itself. We're at 83 degrees centigrade. So these are looking really good. Temperatures rising very steadily. Slow and steady wins the race, baby. But we'll see. Because you guys also have to remember, right? Even the best generator possible probably only has a conversion rate of 50%. So if this machine consumes, let's say it consumes 100 amps, we have to make 200 amps of natural gas to run the generator, to run the machine. You see what I'm saying? So we have to make an absolute ton. Okay, now you saw the flow rate, how it was coming off. That's what we need right there. We need that thing to be even crazier. Hook that right up to the back end of a generator. We are at 88 degrees centigrade, so about 12 degrees away from 100 centigrade, which I reckon is going to be when we start to see oils coming out on the other end of the condenser. So it's looking like today we may actually get oils. Insulating it seems to have done the trick. I mean, we're getting the most amount of vapors we've ever got. Woo! Hot. Oh, I can feel it. It's getting hot even down here. Even down here, it's getting hot. That's what we've been waiting for. We have been waiting for that stainless steel output pipe right there to get hot. And it's starting to warm up. Because once again, going back to it, if it means that is that hot, the oils cannot reflux off of it. They have to go where it's cooler. And guess where it's cooler? Right here with this shotgun, double shotgun condenser, okay? This is cool. And then guess what? The oils are gonna come and drop down right there. So it's looking like, guys, where are we at? We've been running the machine for about 30 minutes now, 28 to 30 minutes. It's looking like we probably will start getting oils coming over in less than the hour mark. It's looking like it for sure. We're at 90 degrees centigrade. 90 degrees centigrade on that pipe coming off of the machine. That's almost 212 degrees Fahrenheit. That's probably about 190 Fahrenheit. Gotta keep it going, keep that temperature rising. It's definitely getting hot, I'll tell you now. Oh, great, I see something smoking on the end of the electronics. Now, I do not smell vapors, okay? Because these vapors that come from this machine when something is leaking have a very particular smell you cannot mistake. So it might be paint or something, but something's smoking. I'm gonna take a better look. See, here's the thing, right? All this stuff is on right now. I touch this stuff, you're gonna see me just, listen, guys, I used to look like Kurt Cobain. I got shocked by this reactor once. Now I look like this. You see what happens, okay? So imagine if I get shocked again. I can't get blacker than this. What the hell's gonna happen to me then? You can't char charcoal. I'm not sure what the smoke is coming from, but also another thing, it's still smoking though. I think it's paint burning. You said, are you ever concerned it's gonna blow up? Yeah, every time I turn it on. Matter of fact, I wonder if these vapors will give us any type of flammability. Fortunately, it's starting to get dark too. Yep, the heat is starting to travel down here to this last elbow. It's the coolest right here right now, but it's starting to get there. That's all that matters. Clearly, I need to insulate the rest of this, but for now, it's okay. Yeah, that body of the reactor is so hot. Goodness gracious. Yeah, this is the hottest the body's ever been. At the few spots I got. Very hot in the body. I wouldn't want to even put your nuts on there out of respect for you. You said invest in a laser thermometer. You're right. I actually used to have one. But let me tell you something that's interesting, right? Those laser thermometers, if you have microwaves on nearby them, they go crazy. They don't work anymore. So, you know, it probably wouldn't work anyway. But I think I actually have a traditional one. Yeah, we still got smoke coming out. I don't know what or where from though. I'm gonna get back here and take a look. Okay, I know what it is. I believe it's paint. So I painted this whole reactor with high temperature paint, right? But you see my magnetron, my waveguides, they're silver. So as I was saying, these waveguides here, you see the paint is silver. That silver paint is not high temperature rated because they're not going to be getting up to very high temperatures or as high temperatures as the body. I have a little bit of overspray of that paint on the body, and that's what's smoking. Let's see. All right, so guys, we have hit it. Right now we are at 102 degrees centigrade on the vapor pipe coming off of the machine. For the first time ever, we have hit a very high temperature, 103 centigrade. So now we are at 212 Fahrenheit actually, over 212, past the boiling point of water on the actual output pipes. So now I'll be damned if we don't start to get some type of oil. Let me take a look at the view glass, because guess what? I think the view glass has some oil in it, guys. Oh my goodness, wait a minute. I'm about to bring you all close, because there's oil coming out the view glass right now. You're about to all see it. There's literally oil coming down. It's dripping down quickly. You've got to see this. We got oil. Diddy is going to be happy, guys, because we got oil. And as I estimated, it was at 100 degrees centigrade. Individually show all you guys. All right? But we got oil. Seriously, take a look at this. Let me flip this camera. Oh, it's hard to show on the camera, isn't it? You can see it dripping down. Look at that. That's oil right there. You see it. Look at the oil. We got oil, baby. We got oil. Hey, everybody. Yeah, hashtag oil up. We got oil, people. We got oil. Take a look, YouTube. Take a look. I got you guys on Facebook next. All right, I got you guys. I'm not gonna for. We got oil, baby. Look at that. It's dripping down, baby. Oh my goodness. 107 degrees Celsius on that output pipe. That means when you open that port down there, we gonna have some oil. We got some oil from plastic right there, baby. We got some oil from plastic coming right there. Coming right at you. There you go. There you have it. You see it dripping down, too. And that's just the start. Now that we got oil forming, leave it running. It's going to make more. The rate is going to start going up. It's only going to increase. We got the first ever oils birthed from this machine right here, okay? We did it, guys. And you saw the temperature it took. These output pipes. Matter of fact, I can touch this output pipe now, and it's gonna be hot. Yup. It's hot now. It's not now. I could put my balls on here for a few seconds, so it's still warming up. Like I said, I really should insulate the rest of this. I ran out of insulation, but the point is, we got oils for the first time. Yup, there's some on this side too. I'm not gonna bring the cameras all the way back here, but it's official. It's official. We got oils. We got oils. You said having leaks at extreme high temperatures is not an option, especially past the auto ignition point. Absolutely, Tony. That's why I do all these pressure tests and I do these low power tests. So that way, by the time we get to the point where we have very high temperatures with all the power going in, it's not even a thing, like, because I don't want to deal with a leak at those temperatures. You're right, it's not acceptable. Let's see if this machine is under any type of pressure now, as a matter of fact. I have my dedimeter right here. My dedimeter. Oh, my bad, it's called a manometer. And anyway, it lets you know. Hey, much love to Pakistan. What's up, Christopher? You said use ice water. Yeah, right now I just got a bucket of regular water. But these shotgun condensers are so high surface area that right now that should be fine. We have a little bit of positive pressure under here, guys. We're at it's fluctuating between 0.3 and it's 0.03 and 0.05 psi. You guys see, it's almost under no pressure, as I always say. And why is it almost under no pressure? Because there's a gigantic hole for everything to go through. You said ice water will make a big difference? Okay, well, hey, why not, right? Thank you for that suggestion, ice water. But fortunately, Christopher, these pipes coming down here are not even getting hot yet. So that means that, but yeah, you're right. Since this machine will operate continuously, that water will start heating up eventually. That's just the truth. Because we've only been running the machine. We haven't even been running we just hit about 40 minutes of running the machine. And we got oil for the first time ever. That's brilliant right there. That's brilliant. That's brilliant. That's brilliant. Oh, look at this. Oh, the thermometer is tripping now. The thermometer is going all over the place, but we're at 112C. 112C on the output pipe of the reactor. Now, I put this on the body of the reactor. It's probably going to be way hotter. This body, yeah, the body is definitely probably in 300 degrees Fahrenheit range, maybe 150C, 140, 150C. Brilliant, brilliant right there. First ever oil. That's why I put this sight glass here. When this machine is running like I want it to, full power, the blade spinning, it should just be like drops of oil. Just like the whole thing should just be golden, right? But yeah, of course, here's the ironic part, right? The reason I use microwaves is because microwaves do not waste as much energy heating the chamber. They use almost all of their energy to heat directly what you want heated, the plastic. But ironically, just because of the nature of science and distillation and chemistry, we cannot, I repeat, we cannot get distillate to come over unless the whole body of the machine and all of the output pipes hit a certain temperature. So ironically, we need the microwaves in the beginning to heat the body of the machine to allow us to get oils to come over. Oh, we got to drop oil. Did you guys just see that? A bit of oil literally dropped down. I love that we can see it. I love that we can see it. You guys are probably too far. But so in the beginning, the microwaves are probably less efficient than if you were to use a regular flame. Well, I don't know about that. Because we're trying to use the microwaves, which are not designed to heat metal, You feel me? In the beginning. But once you get up to temperature, now that we're up to temperature, if we start to load in plastic right now up to this temperature, this is where my hypothesis of the true efficiency kicks in. Because now that we're up to temperature, we can actually turn off certain microwaves. We don't need as many now that we're up to temperature. Put in more plastic, keep it going, boom. More oils, more natural gas, more everything. That's the idea. Unfortunately, I don't have any shredded plastic to put in. So I will not be loading in plastic today. But like I said, today I want to get oil. We wanted to see how long it took for one. That YouTube Live, when we got oil, it was about like 35 minutes in. And then it was right shortly after we hit 100 degrees C on the output pipe, just like I reckoned. Because like that's the temperature of water to come over. So that makes sense. Why that'll be the temperature of the oils to start coming over as well. These pipes are starting to get hot now. This is very hot. I would not want to put my balls on here. Nope, not at all. Which means this is going to start getting hot. So the heat lets us know where the oil is. Since the heat is down here, that means the oil is around here. Did you load the reactor full of plastic and carbon this time? Yeah, it was pretty full. I put a lot in there. A lot in there, Christopher. So, of course, that helped as well. Because more plastic means more points for heat to form with the microwaves, which means the body gets hotter. So then we get things coming over. What improvements you made since the last test run? Insulation. Live completely went out there. My apologies, guys. There's a lot of interference going on. You say, why haven't you started the metal blades? You're right. That's a good point. We got to spin these blades. Sometimes I'm scared to spin them. Because when we spin the blades, it makes a pressure spike. And we always have leaks or explosions happen at that moment. Okay, and no other time do we have explosions when we spin these damn blades, okay? So I get scared, I procrastinate, okay? I stall spinning the blades. All right, let me move you guys down so you can see when we have oils drip. You said with oil production so quick, are you going to reduce the amount of magnetrons? Yes, when this is operating at full power. But right now it's only operating at half power, so we don't want to reduce any more than we already have this thing reduced. But even at half power, this thing is doing good. But I just don't think we're going to get the efficiencies we want until we start to get real power going into this thing. I'm talking about, 6, 7, 8, 9 magnetrons. Well, we're at 6 now. But I'm talking about, 7, 8, 9 magnetrons. So you guys, this is a sight glass. You're going to see the oils drip down from here when they please. Okay? It might be hard to see on camera. I'm sorry about the YouTube freezing, guys. Like I said, there's a lot of electrical interference. You see the oil dripping? Yeah, this is a very exciting, guys. Very exciting moment. First ever oils birthed from the machine. So, You're right, I should spin the blades, and I will, okay? Because we have to. The blades are a part of the machine. So we have to use them. And the only way to ensure the safety of them is to use them. So let me check the natural gas for a second, and then we're gonna go spin the blades. Hey, we got natural gas, guys. I want to show the natural gas coming off. You see it? We got natural gas coming off. Oh, the flame is the flame is half invisible. It comes and it goes. But you guys see it there. Natural gas going right to the yoga balls. We ain't wasting no energy around here. Very clean burning. You see no black smoke, nothing. The flame itself barely even exists. Let's spin these blades now. Pray. Let's pray, guys. We gotta pray. We gotta say a prayer. This machine is under a lot of temperature, a lot of pressure right now. Well, not a lot of pressure, but a lot of temperature. A lot of vapors going on right now. Spinning these blades will only make more. So, if something is to happen, you said just found this page 30 minutes ago, Eureka. Hey man, what's up, Trending Up? I'm glad to have you a part of the family. We made the first ever oils right now live with the Mark 4.5 machine. We've been on a quest for oils for a while now, guys, haven't we? Let's spin these blades. In fact, spinning the blade, look, guys on Instagram, look at this. The oil is literally coming down at a crazy rate. Look at this. You can see it like sliding down. Diddy's about to be oiled up tonight. We're about to supply Diddy with all the oil he needs in prison. He about to have his YouTube. Look at it, baby. We're not even an hour in yet, guys, and we got oils coming out, dripping down. Come on now, let's spin these blades. We haven't even spun the blades. We haven't even loaded in plastic while it's been on. So we haven't even maximized this machine's full capabilities. We're at half power as well. Come on now, it only gets better. All right, I'm gonna put my safety equipment on though. I'm always scared of the blades, guys, I'm serious. We're gonna spin the blades just a little bit. We're not gonna try to like spin the blades to the point where plastic gets down to the end or anything. We're just gonna turn them on just to agitate it and give us new spots for heat. All right, we're safe. Nothing went wrong. Spun the blades just forward and reverse. Just to, like I said, agitate the plastics up. The oil start really dripping. Like I literally see drips just boom. You gotta love the safety sandals, yeah. I actually should have learned my lesson because one time my Mark III reactor exploded and it shot out molten plastic. Now I was even worse then, okay? I was barefoot. And a piece of molten plastic got under my foot and burned my foot. The vapors coming out right now are crazy. But at least I got sandals on. I used to be barefoot, okay? Could be worse. Look at that. Flame is way better. Put that right to a generator. Because we could have this thing constantly being sucked. We put it under vacuum anyway. Oh, I think we got a leak, guys. I think we got a leak somewhere. I smell a leak. I'm gonna smell a leak somewhere. Okay, so listen, guys. There is a leak. Because I can smell it for one. And there's a bit of oil that dripped on the ground down there on that side. I don't know where the leak is, though. The insulation is making it difficult to find. Okay? But here's what we're going to do. We obviously got oil. So let's see how much oil we got for today's run. Because wherever the leak is, obviously I got to fix it. We can't run the machine anymore with a leak. But look how much oil we got. Because we did indeed get some oil today. And we should have some. Well, we have to have some come out right here. It's by nature. Clean this crap out. There's crap in there. Okay, let's see. How much oil did we get today? Don't expect much, but definitely something. You saw it there. Oil. We got oil. Oil from plastic waste right there. You've seen it here. Live. The first oil from the machine. Oh, it's still dripping. Oops. Oops, maybe I should have just... It was still dripping out some oils. Yup. There we have it. You said you blame whoever told me to turn on the blades. Well, we need the blades to be on, so we have to do these testings. But it might have been the smoke I've been seeing this whole time, so the leak might have always been there. But I gotta find that leak and diagnose it, because I can fix it and then have this thing up and running tomorrow, no problem. We're at 151C on the output pipe. Very hot. You said with preheating the condenser to get the oil right away, help with the machine having to heat up? Possibly, possibly. Things like that. What's up, Antonio? So we got oil. So we just hit an hour too. We hit an hour and the machine has to be turned off. What a shame. But we hit an hour. Hey guys, we got oil. You saw it live. Plastic into oil. It might be a little bit. It might be a little bit, but we got it for the first time, and that's all that matters. Because now that we know it works, we know what to keep doing, okay? We know what to keep doing, and we know, we know it works. So that's all we need to see. That's all we needed to see. Only improvements now. So with that being said, I gotta find where this leak is and fix it so we can run it again tomorrow. But this was huge. We didn't even have the blade spinning the whole time. We didn't have the thing operating continuously the whole time. And we still got oil. We still got good temperatures. That's all we wanted to see. So thank you all for tuning in. Thank you for the donations and all your support. I got to find this leak and fix it for tomorrow. But we got an even better run coming tomorrow, guys. An even better run. So I will see you guys then. Because tomorrow, now that we know it works, we're going to be loading in plastic once we get it up to temperature. All right? You guys take care. Stay blessed.